Hi everyone. Can everyone hear me fine?
Yep.
Very cool, very cool. Okay, so today was an awesome day, and we had a lot of interesting talks, and this is going to be the last one before the closing keynote. And I'm going to try to keep it the least amount of boring as I can, just so you know, and keep you entertained and not fall asleep. I'm going to tell you a story about how we used React and Firebase in an unconventional way to leverage leveraging it for real-time messaging. My name is Artur, and I work as a full-stack engineer for a startup in London. I've been working with React since 2013. But I didn't mainly do only React. I did a bit of backend, I did a bit of frontend, and I did some DevOps as well. So I have a broad experience. The startup I work for is called Birdie, and we're trying to make elderly people become more autonomous and be able to stay independent for longer. And the way we try to do that is by making it more social, so they can get involved with their care, be part of their family's lives more real time and more socially. Before the 2000s, being social meant something quite small scale. It was about you knew about roughly a couple of hundred people within which you met every day. You knew your grocer, you knew your co-workers, and you knew your neighbors, and that was it. And it was real time, because human beings are by default real time. We all know that. Then these guys came along and changed everything, and they put on social at global scale, and the real time then actually became a problem, because you can't really do real time the same way people do remotely and at a global scale as well. So it's an interesting problem. But what does that mean to the regular developer? Well, the regular developer is this guy. And it's me, pretty much. So what I want to work on shiny new technologies, and I want to write code, right? And I want my product to scale to a zillion users if possible. And I want to be the next Facebook, I want to be the next Google, and I want my project to be huge. I want to control everything. That's another cool thing to do, in my opinion. But that's a guilty pleasure, and basically it's called over-engineering, because most times you don't need to scale that much. You don't need to control everything, and you need to kind of let some things go. For those of you who don't know, over-engineering is the art of building a bad bike. Building a bad bike is a bike that does what a bike's supposed to do, hopefully, plus 1 million other things. This brings me to an anecdote of sorts I heard a while back, where it was sometime in the space race age, actually, where the Russians and the US were competing to build an instrument to be able to write in zero gravity. And the Americans invested a bunch of millions of dollars and a bunch of hundreds of man-hours into investigating how you would be able to create a ballpoint pen. Who here knows what a ballpoint pen is? It's like the one with the paste, right? The ballpoint pen needs to have the paste flowing downwards. Of course, in zero gravity, there is no down, for one. And basically, they started inventing all kinds of injecting pressure type things to push the paste down. The Russians' approach to this was they used a pencil. That was basically, solving the problem, essentially. This is only an urban myth. This didn't really happen, but it kind of expresses the idea of what over-engineering looks like. So let's start the story. Firstly, I thought, I would design this real-time system, real-time messaging, using Redux, because Redux is open source. It provides the pub/sub channels, which for those of you who don't know is basically a publisher-subscriber, which you can neatly wrap in WebSockets and kind of get the feedback you need. And you also get the Redux CLI, where you can kind of test out the publisher subscribers. Basically, you submit messages on the Redux CLI, and they will get consumed by the subscribers. That's fine and dandy. Of course, it's a servers, and for servers, guess who you need? You need the DevOps guys. Well, mostly ops in this case, but that's besides the point. And then you need an app server, front-end application. Each of them come with their associated developer. So you have the app server with the back-end developer, front-end with the front-end developer. If you have a full stack, yeah, you could do that, but then people don't really scale. And then you have a load balancer because you want to scale. Then here comes the DevOps guy again, and it means a lot of nodes. If you have a lot of nodes, then you need to have centralized logging. If you have centralized logging, at some point the amount of logs becomes unbearable, and you will not be able to figure out anything because you can't really read a log file just by scrolling down. So you're going to have to draw some conclusions based on the exceptions and so on. So that's a bit tedious. So automate everything. Again, DevOps guy. And pretty soon your system looks like this. And you kind of don't want to throw it away because you work hard on it. And you're here and you don't really know what to do, but you have a bunch of people dedicated to maintaining it because you don't want to throw it away. But in a startup, resources are tight, and you're always moving. You don't really have time to hang around and kind of reassess everything. And basically, it's like this picture, changing the wheels of a moving car. Actually, we are 3. We used to be 3. We have an intern now. And of course, everyone knows this guy, the deadline. The deadline is a mythical wall that's in front of us, but most times it's not really. Now, given this and the fact that we realized the system would be a little bit too complex, figured, let's look for something easier. Let's look for something that could help us and, basically kind of kick out some of the extra work that needs to be done. And that's when we kind of found Firebase. And so, okay, Redux does gives you a lot of features, but it comes with a lot of extra work required. So why not use Firebase? It kind of did most of the things, all of the things we need. So, this is a good bike. So let's look at the features of Firebase. Of course, we have the real-time database, which we like, and we use it. Then we have crash reporting, which kind of gives you, for mobile apps, it will give you, the stack trace for your application, of your application crash. Then you have the Cloud Firestore. This is a new feature. It's a NoSQL database with NoSQL distributed database. And then you have the authentication, which is quite nice. It's very easy to build an authentication in Firebase. Basically, you can use GitHub, you can use Twitter, you can use Facebook as a third-party authentication, or basically you can just do email and password. And that's the simplest thing, very easy, just add it. You have the cloud functions, which for any of you, have any of you used Firebase before? Could you give me a show of hands, maybe? No? Yes, there's two, okay. Cloud functions, how about Lambdas or Azure functions? Okay, it's very similar to Azure or Lambdas, so it's pretty much the same thing. Then you have the cloud storage, which gives you easy access to Google. So Google has this way of doing permissions, and you can build the same permissions on these files that you store in the cloud storage. You have hosting, which, it's useful. Then you have the test lab for Android. And then you have performance monitoring. However, the number of features is so huge that I nearly put myself to sleep. And basically, you guys are hearing blah, blah, blah. You don't really know which ones you need for what you want to do. So in our case, we figured we needed the free CDN and SSL, which is good for security and having the assets. You have the easy auth, which gives you a way to kind of shield your message queue from the world. You have the free tier. We've been using it for a while now, and we still haven't run out of it. You have the file storage for storing your static stuff. And of course, because it's Google, you have the automatical scaling, which you do not need to care how it's done. Another very cool thing about it is that if you're coding in a language, programming, then it probably has bindings for it. I have not seen any of them for something that's something like COBOL, but you get C#, you get C++, you get Java, you get Go, Node, Python, and there's actually implementations for all the JavaScript libraries / frameworks that are out there. Well, most of them. You also have a pure JavaScript implementation, which you can use with Node. So it's fairly easy to get started with it, and most bindings will have a similar API. So in order to get started, what you want to do is you create a project, and you select a zone, and then you have your database ready, real-time database ready. And you can see clearly here it's on the left-hand side. You open it, and there you go. That's your real-time queue. To grab the config, which you'll need to create your Firebase object, is you do this from the console. It's on the first page, and it's going to be like 3 buttons, kind of. One of them is for Android, one of them is for iOS, and one of them is for the web, which we're going to use in our demo today. This GIF is a little bit out of date. I think the UI has changed slightly, but it's the same thing, similar. Then you set up your authentication. By default, Google kind of, nudges you in the direction of, you want to be a little bit secure. So by default, it's not going to allow read or writes to your Firebase storage without authentication. And you can set up, some email authentication. And then you will see the the permissions on the Firestore here. And we have basically right now, after we configured everything, 3 steps, and we have a message queue right now. Ta-da! So far, it kind of looks pretty easy to me. I mean, it didn't. If you were using Redux, you would have to set up the server, manage the server, set up the socket wrappers for your pub/sub channels, and the whole thing is pretty painful. But right now, we can use the Firebase library for your language of choice, and you can push stuff to Firebase and then listen on the client side for changes, or listen on, inside your cluster of nodes of distributed systems or something like that, and it's going to work fine. For the purpose of my demo today, what I used is React and Firebase, because I'm a kind of a React developer, I think. And basically, for React, there's a couple of choices, because you can use React in multiple ways. There's the Firebase module, the one on the bottom, which is the basic one provided by Google. And that one can be used with Node.js and any JavaScript you can write and compile and run in the browser. The other two, React Fire, is for basic React. If you guys attended the talk a little bit before this one, I think it was one talk back. It was an intro to React and Redux. I don't know, any of you attended that talk? No? Yes? Okay, so he gave a really good, intro to what React is all about. So I'm not gonna do everything. I'm not gonna explain everything. But yeah, React Fire, you use it with pure React components. And then you have React Redux Firebase, which gives you the extra benefits of Redux state management. Okay, in my demo, I used the pure one, the simple Firebase provided by Google. So in the project, I used Redux for state management, React for the UI, for the components, Python for the backend. I used to be a Python developer and a DevOps guy, so I kind of have a soft spot for it. Then I used Sagas. Sagas are a really cool thing. If you guys, any of you have heard of chunks or middlewares in React Redux, Sagas are a middleware. And then, of course, I used Firebase because that's the kind of core thing in my talk. If I don't say Firebase, I'm not doing well. So count it. Count how many times I say Firebase. Okay, this is the demo. This is what the demo hopefully will look like. Oh my God, the bottom is cropped. How can I solve this? Can we shift the projector a little bit higher, maybe? Or how can I do this? You guys fine? Okay, so basically what that says is this is what I hope the demo will look like, because I never trust the demo gods. Never do. So basically what's there is you guys will log into, well, not log in, but open a URL. It's not spam or not virus E. And you're gonna open it with your cell phone if you guys are connected to the Wi-Fi, and you can tap the button, and basically as you tap the button, the hub component, which is the big screen, will be the big screen, will kind of show a new bubble appearing, and it will grow as you clap. Does that sound like fun at all? Yeah. Thank you. Okay, but first, the boring part. So let's have a look at the code. For the backend, I used Python, and I used Python 3.7 because it's the latest and greatest. Well, not really, but yeah, it's new. So I used it with AIO-HTTP. Is anyone familiar with Python or AIO-HTTP at all? No? Okay. It's a micro framework for building web applications. It's sort of like Flask, sort of like Express, let's say, in JavaScript, or, there's no MVC, there's no huge amount of boilerplate. You just have to write code, give it some endpoints, and it will run. So it's very, very, very small. This is what the structure of the Python project looks like. You're going to have the PyCache, which is for caching the Py compiled files, the PYC. Those are not code. Those are bytecode. You're going to have a server.py, which is the where I set up the application and start the server. Then you're going to have a requirements.txt. This guy is good practice to use in Python projects, because if you guys are familiar at all with Node.js, it's pretty much the equivalent of the package JSON. And basically, you're going to set up the versions of the library in a list. So you're going to be able to do pip install everything in there, and you'll have your virtual environment set up as needed by the project. And then you have the Firebase.py, which is the wrapper around Firebase, and the constants where I store everything. So the username and password, it's in gitignore, so. And the config for the Firebase project I created. Okay, so remember I was telling you about the web app. Okay, the web app, the backend, the API app, so to speak. So you will have two endpoints. One of them is the user joined. The user joined will be accessed through a GET when you guys join the, open the URL I will post. And then at that point in time, you'll get a unique ID, which will then be returned as part of the response to the client. And of course, we want to insert this UID into the Firebase store. This is the user clapped. So when you guys tap on the button, it's gonna send a post request to this guy, and it's gonna hold the user ID to be able to select the bucket, and then it's gonna update the number of claps. Pretty simple so far. If I do say so myself. What do you guys think? Is it like really complex? I mean, looks okay-ish. Here, we set up the routes and the cores. So the cores, these are the, first things first. We start with the routes. We said we had two routes. One of them is join, the other one is clap. This is just the way you use in AIO-HTTP to add a route and the method to it. Then we need to use AIO-HTTP cores to set up cores for those routes, because you won't be able to access them otherwise. This is not production code. I would not use this ever in production because the rules are very loose. So basically, it allows everyone. You should not do that. But this is a demo, so it needs to work. And then you set up cores for those routes. And that's pretty much it for the web app. Okay, now we want to have a look at how we interact with Firebase from Python. So we have our config. This is not Python. This is JavaScript. Looks familiar, doesn't it? But yeah, it's exactly the same in Python, pretty much. So take a look. This this. The only thing I can see different is, well, the fact that these guys actually have values, and the fact that the coding style is, Python style, which in the snake case, and camel case, which is JavaScript style. So that's the whole difference. So yeah, this is how we initialize our Firebase connection. We construct a Firebase object by using the Firebase library. Very creative, if I do say so myself. We use the Firebase and do initialize app of the config, and that's it. You have the Firebase object. After this, I've been going on and on about auth. Well, sorry, I've been going on and on about auth. So yeah, we build an auth object from that Firebase object, and then you generate a token from the user email and password. I used the very simple authentication because I didn't want to rely on third-party access rights and everything. But you could essentially use it with Facebook authentication or something like that. So you can try it. OK, now for the Firebase wrapper. This is where we're going to perform the actions to, update data and push data, create buckets, and so on. The way you do it, you get from the Firebase object, you get a reference to your database. You prepare some data, and if you want to be, really clean, you do like you give it some sensible defaults. The color value there is something that's, something that D3 requires. So it's not it basically gives a random color. The claps are the claps, the number of claps. So once you join, you get like number 0 claps because you haven't clapped once. And your bubble will be essentially invisible. And then, in order to create the first bucket, you select, so in my DB I have a users bucket, and I create the child, and I set the data, but always pass in the token. But you always need to pass in the token, especially if you have authentication set up. So the user of token, and that's basically an object. The user is an object, and you generate that by doing the sign in. Sign up? What was it? Sign in with email and password. So basically here, you pass in the token from the user object. It's pretty, simple so far, I think. Yeah, it is. Kidding. OK, so let's see how we can update an existing key. First, we have, again, grab a reference to the database. And now we, again, select the database and select the child of the user ID. We passed in the user ID through the post request. Remember, the clap, post, clap, and we passed in the user ID. And we're going to get, using the token, the value of the claps in it. And then we're going to do +1, which is an increment. Always remember to pass in the token. The token usually has an expiry default of 1 hour. If it stops working, I would, suggest try turning it off and on again, and I mean the API, because that will refresh the token. OK, so far, what have we seen? We've seen basically 2 endpoints that put data and update data in Firebase from Python. OK, If you were to look at the lines of code that are there, it's basically roughly 40 lines of relevant code that you must have in order to get this working. Everything else is just boilerplate. You start a server, you give it a port, you build a web app, build an app, and so on. It might be even less than 40. But, it's simple. It's easy, it's short code. I wrote this in, I think, 1 hour, more or less. Okay, so we're going to start with looking at the front end. Because JavaScript is very messy, and it's very ugly, and you can kind of get into a lot of trouble if you're trying to build a large application, we need some discipline. So we're going to have a little bit more boilerplate in here. So we have our actions, very well described by the guy that presented earlier, Harold. The assets for static components, which are for the UI rendering. You have an index.js, which will be the main entry point. It doesn't have to be called index.js, it's just what I called it. You have the reducers, which are used to mutate the state. Basically, they're the only guys that should mutate the state. You have the routes folder. This is something I did just to be fancy. I wanted to externalize the routes. You have the Sagas, which are the guys that handle side effects. And these guys will be really cool to talk about. And you have the store, which is the single source of truth. Remember Harold? Single source of truth, and basically it's the only place where you want to store your state of your application. And why do we have such discipline in our folder structure? Well, because if anyone has ever seen a large code base written in JavaScript, it looks like this. It's very, difficult to reason about. If you take one thing out there and you pull it and you take it and everything's going to collapse, maybe, or maybe not. Maybe it's just, so well written that nobody wants to touch it ever. Okay, enough fun. So, okay, this is the entry point of our React Redux app. We give it the store, and we pass it in the routes, which I factored out. This is React 16, and it gives us a really cool feature. You no longer have to wrap your components with an extra component. I really like that, because before, in order to pass a new child to a component, you had to wrap it, and that, in my opinion, kind of I didn't like that very much. But now you can just export a list of routes. And I did that, and it's quite nice because it kind of takes me back to, applications where you have all your routes in one folder and you can check them out. It's easy. You have the attendee route, which is rendered by the attendee component, and you have the hub route, which is rendered by the hub component. And that's plain as day to see. Is everything visible? I think so. Can you guys make it out? Okay, so yeah, this is the hub component. So I decided to talk about this guy because this guy is the guy that kind of reflects best the reactivity to the real-time Firebase store. We have a component did mount, which is a lifecycle method in React. And basically, it will get called once the component has finished rendering. And once the component has finished rendering, it's going to start listening to changes in the Firebase store. the render method of the component. Okay, so you remember Harold? Okay, basically, this guy is the most important method in a component. Every component should have it. And basically, it's the way the component looks like. And this guy is a div, and it has a child component, which is bubbles, and it's gonna render the div, then the bubbles component. Okay, now the prop types, they're not required. I mean, I strongly advise to use them because they so if you are not using TypeScript or, you don't like static types at all, you're asking for trouble most times. And this prop validation gives you some certainty, although not a lot, about what kind of props go into your components. Basically, if this guy was not a function, so prop types func is required. If this guy doesn't get a prop type called listen data, it's gonna complain and show a warning. It's not gonna be an error, it's a warning, but it gives you some awareness of sucky code. Okay, that's a plain component, no state in it. This guy is a container. Why you would want to use a container is because you want to map pieces of your state or give a component the ability to dispatch actions. Here, I didn't really need to map any state from the Redux store into my component, but I did need to give it the ability to dispatch actions. And I did that using this. This is a shorthand method. If anyone's familiar with the other syntax where you do a callable and return a dispatch action, this is the same thing, except it's a little bit shorter. And it's basically a utility method from Redux. It does exactly the same thing. Now, the actions, remember Harold, basically, they need a type. The type's a string. Usually you would do the string type as a const and use it something like this in your functions that return actions. On the second one, I used the parameter as well, the users, for updating. But still, nothing much going on yet. These are the reducers, and the reducers are, I didn't feel the need to split them out because the state is fairly simple for now, but in a really large application you will have state that's very complex. I mean, state management is quite hard in large applications because, I mean, this one only handles 3 types of events, and in a large application you would have hundreds of events, and every one of those single events would trigger a state mutation. And if, basically it becomes quickly unmanageable. So, yeah. Redux uses reducers and only reducers to mutate state. It does so in a pure functional manner. Basically, the state is considered immutable, and what that means is that every single state version is a new object. It's not, it does not have the same reference as the old one. The Redux implementation is not proprietary to React. Basically, it can be used with Angular. In Angular, it's called NGRX, and it uses observables. but with Redux, with React, it's this implementation. But so far, we haven't seen anything. We haven't seen the real time anywhere. Have you guys seen the real time? I haven't. Okay. So the real time is in the sagas. I had it in there because, okay, so let me tell you a little bit about middlewares. Middlewares are functions that hook in between the action dispatched and the store. So basically, it's in the middle. That's why it's a middleware. The sagas give us a lot of middleware utils to handle side effects. By side effects, I mean things that need to have asynchronous actions. So basically, AJAX requests, pretty much. So basically, you dispatch the action will fetch something from the server, but it doesn't do that in itself. Rather, it gets trapped in the Saga. And the magic happens here. It's right there. Can you see it? It's there. Can you see it? I think but I guess you guys like this guy better. Oh. Yeah, I knew. I saw this guy in a talk before, and I had to have the slide, even for no apparent reason. Anyway, so that's where the magic happens. So basically, the actions get trapped there, and they wait for them to finish whatever they're doing. So you have the view layer down in the corner there. You see it? The view layer. The view layer triggers an event. That in turn dispatches an action. The action gets trapped in the Redux Saga middleware, and then it does a request, triggers a request. That request goes to whatever API it needs to, waits for the response, and the effect gets pushed in the store, matched against a reducer. The store pushes the updated state back to the component. Cycle of life. Okay. In my project, what I did was, for the application that you guys will be seeing on your phone, you're going to have the data flow will be something like this. Your UI, you're going to tap it, and then you're going to go to, it's going to create an action, going to get trapped in the Saga. The Saga will communicate with the Python API, and the Python API will update the Firebase store, right? After the Firebase store updates, it's going to return something to the Saga, which in turn will move to the store. Well, the store is around the reducer, so it's going to move to the store, which passes to the reducer and updates the UI. Well, it won't, but because it doesn't need to in our case, but yeah. And yeah, that was a pretty simple case of using sagas. Basically, you can solve everything with a simple thunk. If you guys ever used thunks, I don't know if I asked this before, but have you guys used thunks before? Yeah, no, or show of hands maybe. Okay, so thunks are kind of the earlier versions of Saga. They give less functionality, and once you use it to do really complex things, you're going to wind up in callback hell. And it doesn't give you all the goodies the sagas do. With sagas, you can throttle. So basically, you can make your call, the HTTP calls that you need to make, throttled. So basically, you won't bash your API or debounce them, or cancel them if you want to. And it offers decent error handling in case of failure. But yeah, like I said, asynchronous actions are not the biggest, feature of Sagas. The hub channel, the hub component, is using this particularly different type of component that Saga offers us. And it's basically an event channel, and it allows us to react to changes in the Firebase store. So basically, we will consume in our component all the data changes that come from Firebase. And this is how the hub component works. Basically, the event channel listens, and it listens. And then at some point, Firebase sends, oh, something's changed. And the event channel goes, OK, give me. And it goes to Saga. The Saga goes to the store. Store triggers an action update. And it goes to the reducer, changes the state on the client. And yeah, that's pretty much it. It is a little bit complicated. It's different, but that's how it works. And this is how we could implement this. We import Firebase from the Firebase module made by Google. And we import the goodies from Redux Saga. This is how we would create an event channel. And basically, what happens in this event channel, we're going to have grab a reference to the database, and on value changes, we'll emit a change that will get trapped later in our Saga. And of course, because we don't really want to have references lying around, we turn it off once we're done. OK, that's the channel. This is the Saga. The Saga will trap all. OK, so let's go through it step by step. We're going to create an event channel. And this is going to be the update channel. We're going to listen to changes in the user's bucket. And we're going to dispatch actions infinitely. Kind of looks like it, doesn't it? Well, in fact, it doesn't. It doesn't behave quite like that. What it's going to do is going to listen, and if there is data available, it's going to store it in users, and then it's going to trigger an action to update the users. So basically, in the while running block, the const users will be updated if there is data available, if there is data emitted from that channel. And once that has something, it will then trigger an action to update the users. So it is actually listening. It doesn't just do update users, update users, update users, so on, so on, so on. And then we can wrap everything neatly in a root Saga, which is, like a combined reducers. If you guys know anything about Redux, basically all the Sagas will be here, and if there's an action triggered, it's going to be trapped by that Saga. So user get UID is going to be trapped by the user join Saga, stuff like that. And the listen, update item Saga, the one I showed you before. And now I'm gonna, try the demo. I managed to break it right before the stock, so. OK, I'm gonna sit down for a sec. Oh. Can you guys hear me? Oh, escape. OK, For those of you who do not have a QR code scanner, you can use the URL there. Can you see it?
Do you have to use the URL to log in or something?
You need to just open this URL, and you'll see well, okay, this is a demo, so all gods be with us. But the thing is, you should see a button with a clapping, something like this. Oh, okay, yeah, going here. If you guys do have a QR code scanner, I can post the QR code as well. Yes? Yes? Okay, so just give me a sec. Oh, how does this work? These guys do not have a mobile-friendly site. No, I'm just gonna. What works? What works? Would that work? Can. Okay, and let's have a look at the. Okay, I'm gonna wait for a sec. Waiting. Does it work? Do you see a button? Whoa, that's so great. Okay, and clap? No? Huh. Oh, damn it. Auth token expired. The thing I was telling you about earlier. And just turning it off and on again, and I don't think you should require a new URL. I think I might need to refresh the page.
No.
Oh. Yeah, too many connections. It's like, yeah, I should, yeah. It doesn't allow for more than 20 connections. Okay, so that's 20 people having. I'm so annoyed at myself right now. Yeah. Demo gods, be damned. So sorry about this. Yeah, but basically, you were supposed to see really. Sorry. Okay. Basically, I'm gonna show you what it should look like. Would you guys be happy for that? Or I kind of showed you the GIF before, but I don't know. Something's not. Oh. Give me a sec. Okay, so I think the. Okay. So basically, you were supposed to see something like this, and you would tap, and basically the hub would pick up whenever somebody new logged in, and it would just let you know that you have some people logging in. Should have been awesome. It's kind of fizzled right now because, yeah. And if you refresh, basically you're going to get the new user, and again with the thing. It's weird. Yeah, there you go. It's like 3 users. So sad right now. But yeah, basically, this is going through the Firebase real-time database, and it's a pretty good way to use it as a real-time, well, not real-time, but a messaging queue. I'm gonna go to the rest of my slides. Well, rest. So yeah, that was the demo. Unfortunately, didn't work so well. I tried it a couple of times, but I was not aware that ngrok would limit you. For those of you who don't know, ngrok is something that will allow you to do something like a demo, because you can tunnel outside and gives you a temporary URL for external use. So yeah, I hope you guys walked away with something new from this. Basically, I tried to show you how to build a simple version for message queue in Firebase. And yeah, you can find it here. And I will, basically what I built my demo on is I was hoping to get the clapping in the Medium, if you guys know it. Do you guys know Medium? The article site? And basically I wanted to get the same clapping effect, but I'm still having trouble with the tinsel, the explosion thing. And I will accept pull requests for that. I mean, it's horrible. Me and CSS are like nowhere near. Anyway, my name is Artur, and you can find me on Twitter at this handle. Also, I will be publishing my slides after the talk, so keep an eye out. It's probably going to be SlideShare, and I will post a link to them. Okay. Stay classy. Okay. Thank you.